Hello friends, this is Jitesh Srivastava. As my last lecture, I tell you about data structure and algorithm and little information like what is data structure types, algorithm and relationship, and also I committed to you what will be the next topic. So today I am telling you the recursion and backtracking. So let's start the today videos. So what is recursion? The recursion is any function which calls itself is called recursive. A recursive method solves a problem by calling a copy of itself to work on a smaller problem. This is called recursive steps. This is important to ensure that the recursive terminates each time the function call itself with a slightly simpler version of original problem. So recursion is a such function you can say which calls itself and terminates after a one condition. What is the importance of the recursion? Let's elaborate. Recursion is useful technique borrowed from mathematics. Recursive code is generally shorter and easier to write than iterative code. Generally, loops are turned into recursive functions when they are compiled or interpreted. Recursion is most useful for tasks that can be defined in terms of similar subtasks. Okay, so let's calculate the factorial of positive integer. So this is the sample code of the positive integer. Let's calculate how it is calculated. Factorial n and base case is 0 is 1 means if n is equal to 0 means if your number is 0 it will return 1 and otherwise it will recursive case multiplied by n minus 1 factorial. So function return is n multiplied by factorial n minus 1. So as you can see this function call itself in recursive mode. Okay, so this is the factorial problem. Let's click the another thing. This is the recursion versus iteration. So what is the recursion and what is iteration? Iteration means when you iterate by the for loop. So recursion is terminate when base case is reached and terminate when condition is proven to be false in iteration segment. And recursion is each recursive call require extra space on the stack frame. Each What is iteration? In iteration, each iteration does not require any extra space. If we get infinite recursion, the program may run out of memory and result is stack overflow. Any infinite loop forever since there is no extra memory being created. Solutions to some problems are easier to formulate recursively. Iterative solution to a problem may not always be as obvious as recursive solution. So there is some advantage of the recursion, there is some advantage of the iteration. Okay. So depends on the scenario, on the situation, which technique we need to use. That is in your mind. Okay. So let the GUI representation of a factorial program. Let's suppose we need a factorial of 4. So 4 again it call 4 multiplied by 3 factorial, and 3 again this call the 3 multiplied by 2 factorial and 2 multiplied by 1 factorial, and again this is a 1. So 1, 2, and then 6, and 6 for 24. So 24 is a return from main function. Let's sample code in Java how we write down. This is the function, or you can call it the method in Java. So this is a method, and then pass integer which require your factorial. And let's suppose one another variable for your output. If n is equal to 1, return 1. Otherwise, output is equal to, again call this method to uh, uh, this function called multiplied by n and return the output. So let's I will show into the eclipse. So let's start. I hope you will get eclipse in your desktop. If not, then you can download from the eclipse site. Once you download, it will get your folder, and after extracting it, you will get a. So I will show you eclipse download, and you will get eclipse.org.download section, and here you can download your eclipse into the zip format. Once you download, you will get this type of folder and extract it. You will get this uh, icon, and you will double click and start the eclipse. I clicked here and it will start. So I place the workspace and just launch it. This is just a new eclipse IDE that I am showing to you. We will start when it is opening. Let's check it is start or not. This is your workbench. Um, this is your Eclipse IDE, and start from here, like uh, create a workbench. Once you click the workbench, you have an option: create Maven project, create JEE project, EJP project, Java project. So I'm create a project and simple Java project. So click here Java project. Next, click the project name. I'm putting data structure, and next, and then finish. And there's open perspective, so I'm opening it. Just click the finish. You have a project right now, and then you have to create one class. So I'm creating class. Let's name it Factorial Demo. And this I have to create a package, so I'm creating package test dot data structure. Let's suppose ds data structure class recursion. Some meaningful name you need to define it, so I'm meaningful name defining it here. And then let's suppose I have to create a main method also, so I'm finish. Now you have a main method, and you need to write down the factorial program. So let's do it. Now let's start it. So first we need to write uh, input. For example, you need any input integer like 3, 4, 5, anything. So first of all we need to input. So I am taking the scanner SCANN and pass the sys system dot in. So this is the common practice we are following it. Scanner class we need to implement a java.util. Okay, so now I am system.out.println passing one message, enter the number. Enter the number. Now you have a int, suppose number is equal to get the scanner values. Scan scanner dot next int. So it will get a value from your input and then save into the num variable and then call the factorial. So int int factorial is equal to we need to call one function. Let's suppose fsct fact, suppose function we will create and pass the value of the num. Okay, so what happening? Let the put the cursor here and create a method factorial. So it will create your method here. So now you need to change the implementation to do auto generated step. So int output. Okay, if num is equal to 1, then return return 1. Else we need to pass output is equal to fact brackets में m num minus 1 and then multiplied by number. Okay, and return the output. Put. Okay, so now I need to execute this task, but before that, if I have a factorial, let's show you factorial. So sys system dot, there is a short form syso and control space. You will print system dot out dot println. So factorial of number is factorial. Okay, so now we need to execute it. So let's how to execute? Just run factorial demo.java. So let's see what happening here. It's asking me the number. So I am putting the number of the 6. The factorial of 6 is 72520. Good. So now it is executed. Now let's quick the again run. Enter the number. I put the 4. Enter. Factorial of enter number is 24. So this way you can call your recursion method. I hope you can easily understand. So now come to the my back to slide. This is the slide. So now discussing is backtracking. So backtracking is a form of recursion. In simple term, you have a number of options and you must choose one of these. After you make choice, you will get a new set of options. Just what set of options you get depend on what the choice you made. This procedure is repeated over and over until you reach the final state. So there is some situation where you have a number of options and you choose one. So this way you can find out your path by one. So it's called a backtracking. You have a option number one, you get the option one, it's not work, and then again come to the option two, it not work, again come to the option three, it works. So this approach we can find out our solution. So this is called a backtracking. Okay. So what we will discuss in next topic? I will discuss in next topic is linked list and what is linked list, operations on linked list, and array versus linked list. So stay tuned with us. Thank you for watching.